In this video, we are going to solve the Leetcode problem of the day, and the problem is minimum index of a valid split. So since the description of this problem is too big, let me take you to the drawing pad and explain you this particular problem. We are going to solve this particular problem in O of n time complexity and O of 1 space. In this particular question, we are given an input and the input is an array. Now this array is an array of numbers and we have to give an output of a particular index of this array. So right now this array is having 10 elements. So the indexes are 0 to 9. And what we need to output is some index of this particular array. So right now the output is 4. So this is the index. Now how are we going to find out the output is based on the task. Our task is to split the array into two parts. So this particular index is your split point. For example, if the output is 4, then in this case, you will split your array into two parts. First part will be till 4th index and the second part will start from 5 and go till last index. So now you understood that this index is your ending point of your split. And that is what we need to do. We need to split our array into two parts. Now, how are we going to split? We have to split them such that both the array have same dominant element. Now, what is a dominant element is first thing we need to understand. The dominant element in an array is some element x for which so the frequency of the element x going to be more than half of the length of the array. So right now the length of the array is 10. So what is the frequency of 1? It is 1, 2, 3, 4, 5 and 6. So the frequency of 1 is 6 and what is the half length of the array? It is 5 because the length of the array is 10, so half is 5. So since this is true, so 1 is your dominant element and this is the rule. Just find out the frequency of your element and if it is more than half length of the array, then that is your dominant element in that array. Now let us again see how are we going to split. We are going to split such that both the array should have the same dominant element. Now we have split our array in two parts at the index number 4. So this is your first array and the other part is your second array. Now treat both of these array as different arrays. Okay. If you see in the first array, what is the dominant element? It is 1. So the frequency of 1 is 3 and this is more than 5 by 2. What is 5? The length of our array. So we have a total of 5 elements in our array. So 5 is the length and do the half of it. And the frequency of 1 is 1, 2 and 3. So it is 3. So this is 2.5 and this is 3. So 3 is more than 2.5 and that's why 1 is your dominant element. And same will go for the second case. In this particular array, you will notice that you have 1, 2 and 3. That is 3 ones. And again the length is 5 divided by 2, make half of it, and again this will be 2.5. So again this will have the same dominant element as 1 and this will have the dominant element as 1, and since this point is the split point, 4 is your output. And now you have to make sure that the index which you are choosing should be the minimum. That is, if you are able to split your array at this point at index number 1, then 1 should be your answer. The requirement is wherever you are splitting, both of the array should have the same dominant element. Now to solve this particular problem, the first thing is we need to find what is the dominant element in our array. There is an algorithm which can find the dominant element without taking any extra space and in just single loop. And let us see what is that algorithm. In this algorithm, you will have to assume that your first element is the dominant element. So right now 2 is the dominant element and what is the count right now? It is 1. So at this point, we have 2 as the dominant element and the count is 1. Now, what is the next element? It is 1. So the moment you get the next element, which is not your dominant element, our dominant element as of now is 2, right? So 2 is our dominant element. The next element is 1 and this is not your dominant element. So in this case, you are going to decrease your count and your count will become 0 and still your dominant element is going to be 2. You are not going to change the dominant element, but you need to decrease the count. Now let us see the next element, which is 3. So once you process the 3, first you will have to notice that your current count is 0. So the moment the count is 0, the next element is going to be your new dominant element. So in this case, 3 is going to be our new dominant element and its count is 1 and the dominant element is 3. Now we move on to 1 and again the 1 will say that hey, the next element is 1 and you will have to decrease your count and make it 0 and still your dominant element is 3. Now the next element is 1 and since the count is 0, we need to make a new dominant element. So our dominant element is going to be the next element, which is 1 and its count is 1 and dominant element is 1, right? At this point, you will notice that the next element is also 1. So in that case, the next element 1 is going to make the count as 2. So we have 2 count of 1 and 1 is our current dominant element, right? Again, you will notice that we got the next element as 7 and the moment we got 7, we will say, okay, the current number is 7 and this time the count is going to decrease and it will become 1 and our current dominant element will still be 1. Okay. The next set of elements are 1, 2 and 1. So let us process it. So 1, 2 and 1. So the moment we got 1, we will say that, okay, our count is 1 will become 2. And the reason is our current dominant element is 1. We got another 1. So this time we need to increase the count instead of decreasing it. The count is 2 and the current dominant element is going to be 1. Next is 2. 2 is your next element. So we are going to decrease our count from 2 to 1. And the reason is the current dominant element is not equal to the current element in the loop. So it is 1 now. And the moment you got 1, still your dominant element is going to be 1. And at the last, you will find that your last element is 1. You can increase the count from 1 to 2 and your current dominant element is going to be 1. So once you are out of the loop, you will find that your last dominant element which you found is 1. And this is how you can find the dominant element without using any extra space to end in a single loop. So now using this algorithm, we can find the dominant element. At which point can we split our array and make it two arrays, and both the arrays should have same dominant element. So let us check for each index. What we are going to do is, we know the dominant element, it is 1. And we have to find the count of it. So the count is 6. Assume that this is your split, 0. When you split the array at this point, 0, how many 1 do you got? You got 0 ones. So in the remaining array, we will have 6 ones, right? The total number of ones. So now you will notice that this second part of the array is having the dominant element as 1. And the first part of the array is having the dominant element as 2, right? Since it is 2 and not 1, we are not going to split at point number 0. Now split at point number 1. Check if we can split at point number 1. So we increase the size of our split, and this time that we got that this particular array has total number of ones as 1. So we have 1 1. So the frequency of 1 is 1 and the length is 2, right? The length of this array is 2. Divide the length by 2 and you will find it equal to 1, right? So 1 is more than 1? No, it is not. It is equal to 1 but not more than 1. So again, this array is not having a dominant element as 1. So we are not going to consider this point of a split, and again we need to increase the size of our split. So we will move to the next index, which is this one, and again you will find that the length of the array is 3. The number of 1 you got is total number of 1 you got is 1. So again this is not having the dominant element as 1. Next, again you increase your size at index number 3. This time the frequency of the element 1 is 2. The length of the array is 4 divided by 2. Again this formula is not correct, it is false, right? So in this case we are not going to split at point number 3 as well. But the moment you came at point number 4, you will notice that this time the size of your array is 5 and the total frequency of your dominant element 1 is 3. So since 3 is more than 5 divided by 2, we need to check with the half length of the array. So this is true. So now we know that we can at least divide it from the index 4, but we also need to make sure that the other part of the array is also satisfying this condition, that the frequency of your element is more than half length of the array. So check for the other part as well. So since this part is having 3 elements, and we know that originally we had 6 elements, so the other part will have 3 elements, right? 3 dominant elements. Is this more than 5 by 2? Why 5? Because we know that the length of this particular array is 5. 5 divided by 2, and we found that yes, this is more. That's why 4 is our answer, right? That's what you got in your output. Let us see another case that is very important. Let us see a case where the output is going to be -1. We need to output -1 only in case we are not able to find any index. We can split our array into two arrays such that both have the same dominant element. So in this case, our dominant element is 3. So the frequency of 3 is 4, and the total number of elements in the array are 7. So half of the length of the array is 7 by 2, which is 3.5, and 4 is more than 3.5. So 3 is our dominant element. Okay. Now, can you try to split your array in two parts and see if we are able to find the dominant element in both the arrays? Let us try. Let us try it. Let us try with the index number 0. This time you will notice that your first array is having total number of 3 as 1, which is more than 1 by 2. This one is the length of the array. So yes, this array is having a dominant element, but this array is not having a dominant element. See, here the frequency of 3 is 3 and the length of the array is 6. 6 divided by 2. 3 is more than 3? No, it is not. So right now we cannot split at point number 0, right? Same way we cannot split at point number 1, point number 2, point number 3. If you try with all the points, you will not be able to split the array in two parts. And then the output should be -1. So I think that's it for the explanation part. How are we going to solve this particular question? Now let us move to the coding part and let us see how can we actually code the solution for this particular problem. So first of all, what we need to do is we need to find the dominant element. So let us call the dominant element as mod equal to none. For now, let us assume it's none. Okay. Now, what is the current count? CT equal to 0. And now we need to make a loop for n in nums. Right now we are trying to use the algorithm to find the dominant element. Now, if the value of CT is equal to 0, this CT is going to store the temporary count. And if it is equal to 0, in that case, we will have a new mod as n, the current element in the loop. Also, we need to check if the current element is equal to mod, then in that case, the CT will increase. And if it is not, then the CT will decrease by 1. So this way, after the loop is ended, we will have a dominant element stored in mod. Now let us find the actual count of mod. So ct, let us store it in ct, is equal to nums dot count mod in your array. Now this is the total frequency of our mod. And now let us assign another element current. This is going to store the frequency of mod, the mod number in the first array. That is, after we make a split, the first array will have a count, right? So that is what we are going to store in current. Now I make another loop for I in range of length of nums. Now check if nums of I is equal to mod. If we got the mod value, in that case current value is going to increase, right? And ct is going to decrease. And now we need to check if both the array have a dominant element or not. So let us write that condition. If, let us check for the left array, current is more than I plus 1 divided by 2. I plus 1 will be the length of your left array. And there should be one more condition for the right array, which is ct, that is the count of mod in right array, should be more than length of the nums minus I minus 1 divided by 2. So this will be the length of your right array. And if both the condition are true, so we got the index I which we need to return. So just return the index I. And if our loop is not returning the output, then we know that none of the indexes are going to work and just directly return -1. And that's your complete code. Let me show you the complete code. This is your complete code, right? So this is your complete code. You just need to submit this. And once you submit it, you will notice that all the test cases are passed. And this is a pretty efficient solution as well. And this is a good, and this is a very efficient solution, especially in case of memory. You will find that you are beating around 85% people, right? So you are doing good in case of memory. So that's it for this video, guys. I hope you like the explanation of this particular problem, and if you did, then make sure that you hit that like button, and if you're not subscribed to the channel, make sure you subscribe the channel as well. And I will see you guys in the next video. Thank you for watching, guys.